For this case, we're zoomed in over northwest Texas on a storm just south of the border with Oklahoma on 27 April 2021. The 1-minute visible imagery from GOES 16 shows a storm with multiple storm scale signatures. I'm going to walk through the loop, and as we see the storm develop, it begins to get a crisp anvil edge. I'll go ahead and draw it in. Around this time, you see the crisper anvil edge on the back side of the storm, and followed after that by more growth in the vertical. And as we get a little bit later, we can see those clouds as they get deeper in the vertical being projected by these shadows onto the lower clouds beneath that. So these are all indications that the storm is growing in the vertical, and you're seeing indications of that in the imagery. Also, we see signs of rotation in the low-level clouds at the updraft region down here. On the southeast flank of the storm in this region, we see inflow feeder clouds. Note how those clouds move rapidly towards the updraft region of the storm. As we get a little later into the loop, I'll go ahead and stop this. It's definitely seen much better in the looping imagery, but I'll highlight it here as the area to watch. Above anvil cirrus plume, watch in that direction as I animate the loop. And I'll let this run a couple more times so you can take in all these features that I just discussed. And then after that, we'll look at some different perspectives. At times, changing the perspective of how we view the imagery can aid in visualizing the features of interest. This is a loop over the same time period, except we're no longer on the remapped CONUS sector display in AWIPS. We're now on the native GOES East projection, so that the imagery is not remapped. Compare the storm scale features you see in this loop from the previous animation I just showed on the remapped animation. I'll give you some time to look this over. Now we take visualization to another level as we take the imagery from the native GOES East projection and put it into storm relative mode. This is known as feature following zoom on AWIPS. I'll let this animation play. Ask yourself if this visualization aids in identifying the storm scale features of interest. Next, we'll look at a subset of the previous loop, except we'll rock it back and forth to provide yet another perspective. First, note the inflow feeder clouds on the southeast flank of the storm, and note that they're more readily apparent from this particular perspective. Also note with the updraft region of the storm over here, you just have that sense that this storm is rotating a little bit more readily apparent from this perspective. Also, the above anvil cirrus plume, I'll go ahead and draw in the region to watch. Again, just appears more readily apparent within this perspective of being in storm relative, unremapped imagery, basically on the GOES native projection, and also rocking it back and forth, which allows your eyes to focus in on these various features. Commonly, we'll want to compare the satellite and radar perspective in AWIPS on a 4-panel display. Since we need to have the same map projection for all 4 panels, we need to select a projection to view the 4-panel display. For this example, we're displaying remapped imagery on the CONUS scale in AWIPS. I'll go ahead and let this loop a few times so you can make this comparison. Here's another comparison, this time with the 4-panel display in the native GOES east projection and in storm relative. Note the IR imagery provides additional information in not only cloud top temperature trends, but also detection of the enhanced V signature. The half-degree reflectivity and velocity data on the right side from the nearest radar at Frederick, Oklahoma, provides information on updraft intensity trends. Remember to keep parallax in mind whenever comparing satellite and radar data of a thunderstorm. As you compare the different visualizations, note which ones you prefer so that you'll know what to use for analyzing storms in the future.